In this video, we are going to learn how to take a table and turn it into a graph. And so we remember, because we reviewed it in the last video, that a table is where you have just a whole bunch of numbers broken down by their variables, and it can go either horizontally, or sometimes people like to put it vertically. Kind of depends on what sort of space you have available. And a graph is where you're plotting points, like coordinate graphing. That's the type of graph we're talking about here. So you might have, there you would have X and Y, or this year we learned how to make a 4-quadrant graph. So those are the two types of tables we could do. If you had any negative numbers, then you would need to have a 4-quadrant graph, like that. And just like how we put the independent variable in the X column and the dependent variable in the Y column, on a graph, we always put the independent variable, independent, on the X-axis, and we always put the dependent variable on the Y-axis, no matter which type it is. So over here, that would be the same thing, independent and dependent. All right, so let's start off with a true fact here. Ms. Sherman is currently collecting about 1 egg from every 2 chickens on average on a normal day. And let's make a table for that to start off with so we have something to graph. So I'm going to put the chickens on the independent side and the eggs on the dependent side. I know there's some debate over which came first, the chicken or the egg, but in this context I'm eating the eggs, so the chickens definitely came first. And now I need to fill it with some data. Well, I know that I get 1 egg from 2 chickens, so I'm going to do 2 chickens to 1 egg. And then I'll just fill out my table a little bit. So if I had 4 chickens, I would probably get 2 eggs. If I had 6, then I would probably get 3. If I had 8 chickens, I would probably get 4. If I had 10 chickens, I would probably get 5. That's enough for right now. Okay, so now let's go ahead and graph this. So first of all, we have to decide, do we need a graph that looks like this, or do we need one that looks like this? I don't see any negative numbers in there. No point doing all 4 quadrants. Let's stick with just a 1-quadrant graph, or a 1st quadrant graph, perhaps. So first thing I'm going to do is just kind of carefully count out, make sure I'm going to have enough space to go all the way up to 10 on both axes. And notice that I used my pen to go on the line of my graph. I'm not just like haphazardly drawing lines the way I sort of did up here. See how my line wasn't perfect? But it's okay, it's only a table. On a graph, it has to be perfect. So then I put X and Y to remind myself what goes there, and I'll label it. I'm going to say chickens, chickens, and eggs. And then I need to number. We know how to do this. Start at 0, 1, 2, 3, etc. You're setting up your graph too right now. Great. And then I'm going to plot my points. So these aren't written as coordinates right now. They're written in a table, but that's okay. So when chickens are 2, eggs are 1. So I go over to 2 on the chickens and up to 1 on the eggs. And then when chickens are 4, eggs are 2. When chickens are 6, eggs are 3. When chickens are 8, eggs are 4. And when chickens are 10, eggs are 5. Fantastic. And since I'm describing a trend right here, it's probably okay for me to connect my points. Sometimes we do, sometimes we don't. You could make an argument both ways on this one. Since you probably wouldn't collect half of an egg, then maybe I shouldn't connect the points, because when I connect the points, that means that all the in-between stuff is possible. But we can also connect them to show that this is like the pattern. Or I guess maybe what I should say, to show them that I'm dealing with averages. So like maybe actually half an egg wouldn't be possible, but an average of 1.5 eggs is certainly possible. And then we always want to give our graphs a title. So we might call this one Miss S's Chickens. One more thing about this. If you do choose to connect the points, be sure to use a ruler. Ruler, not just freehand. Ruler. All right, for your practice problem, you are going to make me a table and a nicely made graph, beautiful graph for this situation, where Hazel is 2 years older than Cormac. So H equals C plus 2. I've given you the rule. You're welcome. And I'm even. I am even. Going to help you set up the table. So you're going to have X. What am I doing? We aren't using X and Y. We're using H and C. What are we going to do instead of X? We're going to say that Cormac is the independent and Hazel is the dependent. So you're going to do C and H. Okay, you fill in at least 5 numbers. Keep them small so your graph is nice. And then you're going to make a graph over here, nicely labeled. Okay, good luck. I look forward to seeing your work.